Okay, so hello, the clock is ticking. I think we can start. Welcome to Rusty Frontends. This is a talk about creating frontends for WebAssembly using Rust. Question is, frontends, web applications, does that mean necessarily JavaScript? No, it does not. And this talk is all about this. So this is me. Hello. But I would be more interested about who are you. So maybe you can raise your hands if you are a JavaScript developer or working with JavaScript. Okay, cool. Who of you has some experience with Rust already? Yay, thank you. Hi. So yeah, I'm also a Rust fanboy. I am the current maintainer of Trunk. We will learn later what Trunk is. But I also work at Red Hat as a software engineer. Quick shout out to Daniel. Daniel had a look at the presentation up front, provided some feedback, and even provided a pull request to that presentation. So that is, I think, how open source works. So yeah, shout out to him. We will see him later in the slides because I will mention something that he did. What to expect from that talk? First of all, we will take a look at what is WebAssembly, because I'm not sure you all know about what WebAssembly is. So we make a quick introduction, compare that to JavaScript. And we will take a look at what WebAssembly is in the context of Rust. A quick look also on frameworks and tools. So this is a big ecosystem, so we cannot cover all and everything. But we will take a look at the interesting pieces that we have for this technology in this area. Caveats, because not everything is all good. It never is. So we will take a look at some experience, some things that you might want to take care of or keep in your mind. And then we take a look at why anyway. So if there are caveats, still, why does it make sense? What's the goal of the talk? The idea is to get you excited. That's all about it. Get you excited so that you leave the talk and say, well, yeah, I will take a look. So that is that. Encourage you to learn more, because there's a lot to learn. It's a big topic. What not to expect is that you go out here as a Rust developer for frontends. That we cannot do. And we're not making fun of JavaScript. Not in this talk, I'm sorry. We can do this at the bar, if you like. So, WebAssembly. These are quotes from the WebAssembly homepage. WebAssembly is abbreviated WASM sometimes, is a binary instruction format for a stack-based virtual machine. So, what does it mean comparing that to the JavaScript world? So, in JavaScript, what happens when you have the browser? You basically transfer a JavaScript source file to the browser. The browser takes that, parses that, and then starts to interpreting the instructions that are in there that it parsed and compiled on the browser side. WebAssembly works different. So what WebAssembly does is you have a tool chain up front that does the parsing compilation process up front. It creates a binary, which is basically a blob, and that will then get sent to the browser and executed in a virtual machine there. So for those of you who are a little bit older, like me, you might remember Java applets. Yeah, it sounds similar, and it is. WebAssembly 1.0 has shipped in 4 major browser engines. That's what they say on the homepage. Let's take a quick look what that looks like. Chrome, Firefox, Safari browsers. That includes Edge, by the way, too, because that's Chrome-based. These are all browsers that do support this. They do support all kinds of features, additional features, add-ons for WebAssembly too. So yeah, no problem, even on mobile browsers. Node.js, Deno, and a few other runtimes you see here too. So those are runtimes that basically on a normal computer run WebAssembly too. So it's not only limited to browsers, but you can run that elsewhere. A quick screenshot on what WebAssembly can do in addition to what we talk about today. So you can compile C++ to WebAssembly too. You can compile Go or other things to WebAssembly too. Does that necessarily mean that you can create one function in C and C++ and the other one in Rust and just call from the C to the Rust side? No, it does not. Because if you, again, keep in mind this idea of you're compiling this into a binary, then this is a binary. So there's no specification for calling from language A to language B. Yet. There is a module system that currently is being developed and defined where the idea is that you create WebAssembly modules where you specify a type system so that you can actually call from a C module into a Rust module and back. So that's future work. If you're interested in that, maybe check it out too. Take a look at how this looks in the browser. So again, you have those two virtual machines running there. You have the JavaScript side and the WebAssembly side. By default, it's running the JavaScript engine, of course. Every browser does that. And then you start instantiating a WebAssembly module. So this is this blob that you download somewhere. You tell the browser, OK, this is my blob, this is the module, instantiate that, and then run it. And as part of that process, you can take functions from the JavaScript side and hand that over to the WebAssembly side and say, these are functions you may call. So the WebAssembly side can call back into the JavaScript world, which is important because the web APIs, all these kinds of DOM manipulation and the browser sensors and whatever, these are APIs that the browser on the JavaScript side has, and you might want to make use of those on the WebAssembly side too. On the back channel, the WebAssembly side can define some functionality that can get called or exported to the JavaScript world. So the JavaScript world can call into the WebAssembly world when that is necessary. So this is basically some kind of linking going on in the instantiation process. What does it mean in the context of Rust? Because this is so far pretty basic WebAssembly. So if you know Rust, a build in Rust is pretty simple. You have Rust code, you run cargo, you get a binary. And that's what you have here too. So there is the WASM32 target in the Rust toolchain. You have to install this in addition. Pretty simple, pretty straightforward. It's a tier 2 target, so it's with every Rust release you will have that. You compile it, and you get the binary. Running that, of course, means that in the browser you want to have probably some kind of index HTML file, which you load in the browser, and then that loads the WASM application. So you need a little bit of basically glue code to get that started. And this is how this looks like. So this is instantiating on the JavaScript side a WebAssembly module, then passing in a function, which is here just an empty function on the JavaScript side. It could call anything else. Like on the JavaScript side, you could call any API that you have or just provide some custom code. And then you see, once this is instantiated, you can also call into the Rust functionality on there. And the way back, so assuming like this is Rust code, that gets called somewhere from the JavaScript side, you can call back into the browser API, the console log functionality. What you might notice here is that you have the log_1 name, because Rust doesn't support overloading of parameters. So the APIs will look a little bit different. But you can also see that, yeah, it looks similar. This is an example on how you would define functionality on the Rust side that calls into the JavaScript side. This is an inline snippet, so you can just write JavaScript code. And then you have the snippet test functionality, this snippet test function defined here, that you can use in your Rust code. It's not necessary to have inline JavaScript all the way. You can also have just existing JavaScript modules that you just define here as a file, and then the whole toolchain we see later on will take care of that. So again, to that picture, Rust code gets compiled into WASM, and then you have the WASM bindgen, which uses those annotations you saw before to create glue code on the JavaScript side. So all this exporting functionality, you do not need to define that yourself. There's tooling for that happening. Of course, a web application is a little bit more than just the code. You have assets, you have images, you have CSS and whatnot. You want to collect all those snippets into a distribution folder. You want to have things like sub-resource integrity later on, so that you ensure it's not manipulated what you transfer. And you, of course, will have nice experience when it comes to developing, hot reload. So you change a file, it reloads, and you see the result immediately. And there is Trunk. Trunk is a tool that can enable you to do that. So Trunk basically is there to build, bundle, and ship your Rust WASM application to the web. WASM application, keep in mind, this is a front-end application, so we're not talking about any WebAssembly application that you run on the command line, but this is targeting web applications, front-end applications. What does it do? It orchestrates a web front-end build. So it doesn't do the build itself, but it calls cargo, it calls WASM-Binder, and calls all the other tooling to do it for you. It uses existing tools and dependencies all in there, so it's, again, like just bringing things together. And it allows you to start simple and then go for more complex configurations, meaning that you can actually have a proxy for serving. So you have a front-end application you want to call into backend. You can configure a proxy to call it to your corporate instance of the backend that you want to talk to for development purposes. Trunk is available on Crates.io. You can download it from GitHub releases as a binary. Fedora has it out of the box. There's on Brew. NixOS has also a package for that. So it's easy to get it, install it. There's a bunch of features that Trunk supports. It tries to make it easy for you. So again, like you might need to have some tooling, WASM-Binder that you download, things like that. Trunk does that for you, except if you want to use the ---- offline flag, which might be important if you run into a Docker container, the build process, or if you have NixOS where people don't like just downloading random stuff from the internet, which I can understand. Asset processing, post-processing is all in there. So a quick shout out to the currently released version, because mentioned before, I'm a Trunk maintainer. So I'm happy about the release we did a few weeks back, or a week back, I think. New and noteworthy is this cargo profile support, which might be important if you share the front end and the backend code in the same project. There's OS-specific hook overrides and a revamped configuration system, which not only allows you to use TOML, but also YAML, JSON, cargo. So putting information, metadata, build information for Trunk in the cargo TOML file itself and making use of that. So that's all tooling and interesting features that we have. But basically, we have an empty canvas. So we want to create an application. We want to build something. What options do we have on the Rust side there? So you could go for that, which basically means you're calling specifically into the web APIs. Like you can do this with JavaScript too. Get the window, get the document, get the body. You see, you have to deal with all those exceptions that JavaScript can throw, and it doesn't look pretty. However, there is a way that makes it a little bit more convenient, which is the library called Glue. So Glue is providing basically a wrapper around web APIs that look ugly in Rust side because of how it's all defined, and make this work more nice. So still, if you see that function calling the body to get the body of the document, that might panic. And panic, if you work with Rust, you know what that means. So it doesn't solve that issue, but it just hides that, which is good enough because it would happen the same way on the JavaScript side anyway. Still, this is not what you want, probably. So you want to have something like React.js, have a nice toolkit. And these are toolkits that exist on the Rust side. There's a bunch of those, and as this works in the web world, new toolkits come along and they go. So we will take a look at 3 that are currently pretty active and pretty interesting, at least I believe, and the GitHub stars also do. So there is U or Jew. I'm not sure how this is pronounced correctly. It's an established framework. It's slower when it comes to releases, which may be good for you or maybe not. It uses the idea of virtual DOM, and it's heavily inspired by React.js. On the other side, we have Leptos. Leptos is growing fast. It's pretty many releases. It's using Rust nightly features, which if you use Rust, you might know what that means, and you might not like that. It is more inspired by Solid.js, so it works a little bit differently, and it is actually pretty fast. And in the middle, you maybe have Dioxus, which again is a framework that is interesting, but we will not take a look at that today. We will take a look at Jew and at Leptos. And this is basically how a Jew application looks like. This is Patternfly. Patternfly is a toolkit similar to Bootstrap or Bulma or others. It's using all kinds of components. You can expand sections. You have a table tree, all this running in Rust code. And if you take a look, this is the source code. It's not the same source code for the application we just saw. That might be a little bit complex. But this is how a component, an example component using U might look like. If you know React.js, yes, it looks familiar. But of course, it's using the Rust type system and features around that. So how do you get started? Like starting from zero, setting up a new application. So first step is you install Rust. So this is the first line. You just go there, install Rust. That's it. Second step is you have to add that WASM32 target. Again, this is like out of the box with every Rust release. However, you have to install it manually yourself if you want that, because not everyone wants that when downloading Rust. Third is install two tools, trunk, which you need for running that later on, and then cargo generate, which is important for the next step, where you just set up that template. Finally, you run trunk serve, and that's it. Switching over to Laptos, so this is again where Daniel comes in. I was looking for examples in the trunk community to say, well, who does something with trunk in a productive way? So he shouted out to me and said, well, this is something he did. So there's Evo 2024, which is an esport event, and they have actually some like management application for the setting up the event or scanning QR codes, entrance, registration, all this kind of stuff. And they wanted to have an application that scales with the event. Now they had an existing React.js application and they weren't sure if this will scale or not. And yeah, also Rust is fun, so they just re-implemented that backend, frontend in Rust. There's some interesting statements, including those that I mentioned here. If you're interested, read the blog post. It's pretty interesting and has some insight on what to do and what not to do. And this is a Laptos example. Yeah, looks familiar. Doesn't look too much different. Going in the same direction. So let's take a quick look at caveats, because again, it's not all roses. There's technical on the con side, technical caveats, and you have to just acknowledge the web is JavaScript first. That's currently the situation. What that means is that you might have tools or functionality or CSS stuff, all these kind of things that you have as JavaScript, for example, and then you need to wrap this, as we saw before, for the Rust side. So can you use popover? Yes, you can. You just have to wrap this, the functionality, so that you can use it on the Rust side. What is interesting is that some of those JavaScript dependencies or JavaScript thingies actually under the hood now use WebAssembly. We will see later on an example of that. So the world there is changing also a little bit, acknowledging that WebAssembly has its benefits too. All of that means that you still need some JavaScript expertise. So if you think, okay, I have no idea about JavaScript, going for a front-end project, that might be tricky. On the social side, hey, some people just enjoy JavaScript. So if you go to your developer team, front-end, all JavaScript developers, and say, well, we rewrite everything in Rust, be careful. That might not be accepted. There's definitely the fact that there are more JavaScript front-end developers than Rust front-end developers. So if you're hiring for front-end developers and you say, well, give me some Rust front-end developers, that might be tricky. So that's also something to consider. On the other side, if you don't have those front-end developers for JavaScript, you only have Rust back-end developers, that argument might not matter. So we see later that that might actually be on the pro side of things. And of course, whenever you search on the internet for things like how do I do this and that on the browser, you will always find JavaScript examples. So you have to translate that into Rust yourself, which boils down to this argument, okay, the web is JavaScript first. So why do that anyway? And that's the pro side. So the pro side, and also Daniel highlights that in his blog post, and I've experienced the same in projects. You can use the same language for backend and frontend. And that can be a huge win and make things a lot easier, because you just make a pull request changing the backend and changing the frontend at the same time. Now you can say, well, you can do that with JavaScript too, right? So you can write your backend in JavaScript and create the frontend in JavaScript at the same time. Yes, however, there are good arguments, and they are not part of this talk, why you want to have a backend in Rust. Or why you maybe want to have a backend in a different language. But if you go for Rust, then you can actually leverage again the same language and the backend and the frontend. Look how fast it is, and we will do that in the next slides. And then, at least personally for me, Rust is just more fun. and some people do agree there. So if that works for you, then maybe think of that. There's a bunch of topics or bullet points I put not on this slide, because you might think, yeah, well, Rust has so many more features or safety features, memory safety features, and all the lifetime checking, borrow checker. Why is that not on the slide? Well, memory safety issues are not a problem normally if you run just JavaScript code. JavaScript does not have anything like that. So that is solved by JavaScript in a different way. On the other side, you also have state issues sometimes on the JavaScript side where mutability can be an issue, and Rust saves you from that with a borrow checker sometimes. So this is all good arguments, but the focus here is really on the front end part. So a different statement from a different project. So you might know Matrix, the chat protocol. The Eclipse Foundation uses that too. There is Element, which is the front end. There's an upcoming new front end, or like version 2 front end, Element X. And the team behind that actually wrote a blog post about why they're making the changes they do. And one of the bigger changes is they are using the Matrix Rust SDK as core of their front end. So the original front end is written in React.js, or JavaScript, React.js, and all the crypto in there too. So what they're doing now is they're replacing that using the Rust SDK, compiling that to WebAssembly, and then using that as part of the direct front end. One thing they get out of that is that using the same SDK, you can not only compile to WebAssembly, but you can compile to iOS and Android and a bunch of other targets too. So you have a single implementation of all the crypto stuff, which is pretty complicated. You fix an issue there, you fix this for all your other targets too. Taking a look at performance comparison. These are different frameworks that you have, including Vanilla.js, comparing the performance. And there's a link in there where you can check this out yourself. This report has a lot more frameworks too, but these are like matching ones for this talk. So you see Laptos, Daxos, and you outperforming React.js. You see also on the left-hand side Solid, which is pretty fast too. So depending on which framework you use and what use case you have, the Rust side actually does pretty good, even outperforms it sometimes. But of course, there's JavaScript parts which can give you good performance too, but at least you don't lose much. So if this is the argument, because think about this WebAssembly JavaScript picture from before, if you're changing the DOM tree, if you're rendering in the browser, you have to call from WebAssembly to the JavaScript side. So this back and forth might cost you performance. So the longer you stay on the WebAssembly side, the more performance you get out of this. Thinking about the Element, Matrix, SDK from the previous slide, for example. And this is one example where this actually provides you a huge benefit. So Lightning CSS is a toolkit which minifies CSS. And minifying CSS, taking lots of information, parsing the CSS, optimizing that, that is actually used by Trunk. Lightning CSS is written in Rust. Trunk uses that, compiles that as part of the native binary for minification of CSS. But this is also used as a Node.js dependency. So when you use Lightning CSS, you see quite good performance when running compared to JavaScript competitors. It gives you good output too, so the performance of the application is actually rather good. And this is how it looks from the developer side when you make use of Lightning CSS. You don't even notice that there's WebAssembly and Rust included. You just use it, you get better performance. And this is one of those examples where I mentioned before, where you have a JavaScript dependency, but underneath it, it's actually something different. Of course, there is more. There's a huge ecosystem going on around that. So I just want to highlight two more, which might be interesting. One is Tauri. Tauri has a lengthy explanation of what they do, and I think it's easily summarized as it's kind of like Electron, but with a polyglot aspect. So the backend can be in Rust, the front end can be in Rust, the front end can also be in JavaScript. They're working on a Go backend. So if you have an interest in that, maybe check that out in addition. And then there's Bevy. Bevy is a game engine. So Rust is famous for creating game engines, and that one can also target WebAssembly. And now with a little bit of luck, we will see how that looks. So yeah, that is Rust rendering with a game engine on Bevy, and you can actually like let the fox change here, speed, whatever. So that's what you can do. And for game engines, performance is also something that is important. So now what? How can you start? What can you do with what you just saw? My advice would be go and explore. So if that like sparks the idea of, hey, that could be interesting to us, go and explore. Start small. So there's lots of tutorials where if you start small, you can easily try to replicate that, get started. Start fresh. Don't take something you have and rewrite that in Rust. That will be frustrating because you know how you did that before and it works a little bit different. And one important part is embrace JavaScript when it makes sense. So don't try to avoid it because there's a lot of good stuff when it comes to JavaScript, which is already there. Try to embrace it. And actually, Daniel, the guy I mentioned before, took that advice, and he took that presentation that we see right now and transformed it into Reveal.js, which is a presentation framework in JavaScript, and turned that into Reveal.js using Rust. There are a few links which might get you started if you're interested. So most important is the Rust WebAssembly book. The Rust WebAssembly book is not only about frontend, but about WebAssembly with Rust in general. There's Wasm BindGen, a book about that, which explains you all how you map the different types of JavaScript into the Rust world and back, so that you can like create bindings for TypeScript for your Rust code, for example. And there's this presentation as well. A few more links. Trunk, we talked about that. There's Wasm Pack, which is a competitor to Trunk. It has a little bit less functionality, but still, it might be interesting. There's you, Laptos, and of course, there's Tauri and Bevy. And with that, we are at the end of the slides, but I think we have time for questions. So why not quickly add a slide for questions? So we just take that and switch back. And there we have the live coding session. Creating a new slide. Trunk is running actually in the background, serving this presentation. It detected a code change, reloaded that, orchestrated the build, recompiled that, sent with a WebSocket a notification to the front end that it should reload, and there you have time for questions.
Okay, after, yeah? Questions after,
Yep.
or? Yeah. How smooth is debug experience?
Debug experience, yes, good question. Debug experience, you can actually run the Rust code in your IDE. Like just you saw that I'm using IntelliJ or Rust Rover, basically. So you can run that there and can debug the code there without running in the browser. You can also run that in the browser with the Chrome Web Console. So there's support for that too. There's a caveat though. Again, there is some mapping information that is currently missing. And there's an open issue on the trunk side to orchestrate that too. Pull requests are welcome. Yeah. No more questions? Okay, then thank you for listening.